Hello, my name is Sydney Carr, and this is my ENME 435 Smart Doorbell project. In this video, I'm going to show you my full setup, the algorithm I implemented, along with a live demonstration of motion detection, video recording, and email delivery, all with a Raspberry Pi, camera, and Python. This is the physical setup. I'm using a Raspberry Pi 4 connected to the official Pi camera module via the CSI port. I'm accessing everything remotely using VNC Viewer on my MacBook, which also allows me to view and transfer files wirelessly. My code is run directly on the Pi using Python 3. I've written a script called smartdoorbell.py that continuously monitors the video feed for motion using OpenCV's frame differencing. Once motion is detected, it captures 2 images and records a 10-second .h.264 video. It then converts that video into a MP4 format and emails the video along with the 2 images to a Gmail address that I created for this project. Here is a quick overview of my code. At the top, I define motion detection parameters, email credentials, and folder paths. The detection function compares frame differences to identify significant motion. I then store the first image at the beginning of the event and another about a second later during the video recording to capture different frames. After the video is saved and converted using FFmpeg, I attach the images and video in an email, and the Pi sends it directly to my inbox using Gmail's SMTP server and an app password. Now I'll run the code and demonstrate the detection in real time. Here you can see motion was detected, 2 images captured, and a 10-second video was recorded. And now here's the email I just received. It includes both still images and the full video, confirming that the system detects motion and sends the footage autonomously. To make the algorithm work reliably, I adjusted a few OpenCV parameters. I used the Gaussian blur with the kernel size of 2121 to reduce noise and create smoother frame comparisons. The detection threshold was set to 1,000 pixels, meaning a change in 1,000 or more pixels between frames triggers a motion capture. The delay between the first and second image is intentional. I wanted the second image to reflect the moment during the 10-second video to ensure temporal coverage of the motion event. If I were to improve this further, I'd like to add a live stream preview to a web dashboard, or maybe incorporate a PIR sensor to trigger recording more efficiently. I could also add object classification to reduce false positives from things like shadows or pets, which I did experience throughout this project. I did make several improvements compared to our base detection. I added automated email delivery, converted H.264 to MP4, using FFmpeg, and a failsafe that skips motion checks if the camera is unavailable. This helps with long run times. This project has helped me understand computer vision Python scripting, and integrating hardware with cloud-based notification systems. It's something I could definitely see myself building on in a real-world setting in the future. Thank you for watching.